Hey guys, welcome back to Ozzy's Young Learning Emporium. In this video, I'm going to be continuing with logarithms. So this is part 2. In part 1, we talked about what logarithms are and why they're so important, the natural log. We talked about all of that. So if you haven't watched that video yet, I highly recommend that you do so. The link is in the comment box down below. But without further ado, let's get straight into this video, and we are going to be starting by talking about log rules. And basically in this video, we're just going to be practicing them, seeing where they apply, how they really work, and that's basically all for this video. So let's quickly get into this. So what are log rules? So there are 3 log rules that I think are really important to know. So there are 3 log rules. Yeah, the first one is called the product rule. So that states that if you've got log base anything basically and in brackets you've got AB, log A plus log B is what that means. So basically if you've got log AB, that is equal to log A plus log B. So you can split it up. That's a log rule. So this is called the product rule. And let's look at an example. So of the product rule, we've got log 1 plus log 10. Now, I'm just gonna hide this really quickly. So, we've got log 1 plus log 10. How do we go about this? Yeah? So guys, don't look at the screen for a sec. Okay. So, how do we solve this? So using the identity that we just looked at, we can understand that this would equal to log 1 times log 10 because we have log A plus log B. So here A is our 1 and B is our 10. Yeah? So basically that's how you can think about this. So we can write this out as log 1 times 10. Now 1 times 10 is 10, so this becomes log 10. And since our base over here, our base is 10, this is the rule that we talked about in the previous video. If there's no base specified, then the base is automatically 10. So that's why this becomes log base 10, 10. So what number do we need to raise 10 by in order to get 10? That would be 1. So that's why we can use the log product rule over here in order to solve this very easily. Because it's so hard. I mean, it's not really that hard in this case, but it's just gotten a lot more simpler. You just combine it in your mind, and it's easier to do 1 than to do 2, right? So that's why it's just a little shorter way to go about this specific question. But let me show you another example. For this question, we've got log base 8 to 4 and plus log base 8, 16. Over here, why is this harder? Because in the above one, we had log base 10, 1. And basically, we know that any number to the power of 0 is equal to 1. That's just a rule that you should know. So any number to the power of 0 is equal to 1. That's why if we see log 1, log base anything 1, that means that is equal to 0. And since we know that log base 10, 10 is 1, this is really easy to solve even if you don't know the identity. But this one, what would be 8 to the power of what is equal to 4? Well, it's not half, by the way, because root 8 is not a perfect square. 8 is not a perfect square, so that won't work. That's wrong. That's not what it is. So 8 to the power of what is equal to 4? That is going to be hard to do in your mind. You need a calculator for that. So to do this easily in your mind, what you can do is you've got the product rule, and you can go ahead and multiply these numbers to get 4 times 16, which is 64. But now we know that 8 to the power of 2 is equal to 64, right? Because 8 times 8. 8 times 8 is 64. And that's why this is so much easier, because we can just know that the answer to this is 2. Because by themselves, each of these don't really make sense. You can't, I mean, they do make sense, but like you can't really do them in your mind. But if you use the log rule, you can. So let's just move on to some questions from here. So I want you to attempt these by yourself before I explain how to do them. So I want you to expand log 3x. So we just want 2, so we just want log something plus log something. That's all you need to do for this one. So I'll give you 3, 2, 1. I hope you've paused the video and given it a go. If you haven't, that's okay. Let's just solve it together. So since we know our log rule, is basically log A plus log B is equal to log AB. We can use that over here. So expanding this, we would get log, what is our A over here? We've got two numbers over here. So A can be 3, so log 3 plus log x. And that's our answer. For this one, I will give you again 3 seconds to solve this log 7ab. So 3, 2, 1. I hope you've paused the video and given it a go. If not, again, let's solve it together. So we've got 3 over here, 3 numbers, and we can fully expand this, by the way, even if there are 3 numbers. So we get, so our log a can be log 7 plus log a, because, well, b becomes our a, and then log this number b. You know why this works? Because if you just combine these two, you get log 7a plus log b. And if we use the identity over here again, then we would get log, oh my god, my handwriting is really bad right now, log 7ab. So it all comes down together. It all combines really nicely. So let me just write this out one more time. So we start with our first number. So we go log 7 plus the next number a. So log a will not number variable plus log b. Okay, even though if there were lots of more terms, we can always expand it like that. So that's something you guys should know. Okay. Now let's move on to the next rule, which is the quotient rule. So I'm just going to scroll up and show you the quotient rule, our second very cool rule. So that is, if we have log a divided by b, that is equal to log a minus log b. So very similar to the product rule, but the only difference is that we're taking away log b from log a instead of adding them together. See, since multiplication is the opposite of division, we can think of this as flipping our signs over here. Yeah, so this is again pretty simple. So let's go with some examples really quickly. So I'm just gonna hide all of this, so just look away for a second. So if we have log base 2, 256 minus log base 2, 16, how would you solve that? So if you like, you can attempt this by yourself, but this is an example, so I'm gonna walk through it very nicely and explain it very well. So I'll give you 3 seconds. If you want to pause the video, give it a go. So 3, 2, 1, let's get into it. So, well, if you have played the game 2048, then this should be easy for you, so you don't even have to know the rule in order to do this. But for those who haven't played that game before, if you don't know what game I'm talking about, that's completely fine. Then just focus. What we have to do over here is that we can express this using our quotient rule, right? So our first step would be dividing, because we see a minus, so this can be used, the quotient rule can be used. So we can assign this to a and this can be b. So now we will have log base 2, 256 divided by 16. That's the same thing because we just converted it, right? So we have our a on the top, we have our b on the bottom, so that's completely fine. The next step, we simplify to 56 over 16, which is 16. Now, let's just do this together. So, we know that 2 to the power of 1 is 2, times 2, so 2 to the power of 2 is 4, then times 2 again, 2, so this is 4, now that becomes 8, and if we do it again, we get 16. So how many 2's do we have? We have 4 2's, and that is why 2 to the power of 4 is equal to 16, and that's why this would evaluate, the answer to this would be 4. Pretty simple, right? As long as you know what you're doing, it gets really easy. So now, if we look at the next question, we have to expand log base 4 x over 4. This is, again, very easy. We know the quotient rule. Let's get straight into it. We know that this is our a, this is our b, and we just go from there. Yeah? So now this becomes log a minus log b. So our log a is log x, and log b is log 4. And we can't forget the little bases on the bottom, which I did forget in my example. And this can be further simplified into log 4x minus log 4. Now think of this one only. How can we simplify this? We have discussed this before. 4 to the power of 1. Any number to the power of 1 is equal to itself. Yeah? So this is just equal to 4. So that's why this little bit over here just becomes minus 1. Okay? So again, very simple as long as you know what you're doing. So let's look at these two questions where we use our quotient formula, quotient rule. So the first one, condense log x minus log 5. Now by condense, I mean that we need to get it into the smallest little, so just get it into one term if that's possible, yeah? So what do we do over here? We know that this is our quotient rule, so we need to get this in the form of log a minus log b, and that is equal to log a over b. Yeah? So over here we can easily identify that this is our first term, this is our second term, and thus we've got this is going to be equal to log, we know that our a is therefore x, right? So we know that our a is equal to x. We know that our b is equal to 5. So that's why this becomes log x over 5, as our quotient rule suggests. Okay, now the next one, in this one we have to just simplify this. Okay, what is this equal to? Yeah, so again we're going to use our quotient rule. So this one, we can see that the number we're taking away from is this. So this is going to be our log a term. Yeah, and then this one is the one that we're taking away. Yeah, so this is going to be our log b term, and since we're minusing, that is equal to log a over b, right? So that's why what we can do is this is equal to log 1000. So that means our a is equal to 1000 and our b is equal to 10. Yeah, so that becomes, that whole thing, this whole thing is equal to log 1000 divided by 10. And if we cancel out the zeros, we've got 100 over 1, which is equal to log 100, and that should be down here, is equal to 2. Because what number do we raise 100 in order to get, what number do we raise 10 in order to get 100. We raise it by 1. By 2. Okay? Now, once again, let's look at our last rule. This is called the power rule. Again, very useful. This is probably one of the most useful log rules that you're going to see, but again, they're all almost equally as useful. Okay, so this rule states that if we've got a log of the form log a to the power of n, we can manipulate it so that the n kind of comes to the front and it becomes n log a. Okay, so how does this kind of play out? So if we've got something like I'm just gonna cross this out for now. Okay, so if we've got something like log x to the power of 5, how can we manipulate this? Well, what we can do is, once again, cool, beautiful. So what we can do is we bring the 5 to the front, yeah? We bring the 5 to the front, and that becomes 5 log x. Simple, right? The next one. In this one, what we can do is we bring the 16 to the front, we bring it to the front, and we get log 8, 64. Now, before you do any of that, if we didn't have this, if we didn't know this rule, this would be such a hard question to do in your mind, right? It's pretty hard. You can't really do anything about it if you don't know the exponent laws or the log rules. So if you know the log rules or the exponent laws, it gets a lot easier. So we bring the 16 in front, it becomes 16 log 8, 64. We know that 8 to the power of 2 is equal to 64, right? So what this becomes is 16 times 2, because our basically whole log 8 64 becomes 2, because it's just the more simplified version of it, because 8 squared equals 64. Easy, right? So that's what happens, and 16 times 2 is 32. Okay, I hope this is going well for you guys and you're understanding everything. So now let's look at some questions. So log under root x. Now, we don't like under roots. We don't like square roots. They are hard to deal with. This whole symbol, it can get confusing at times. So what we're going to do is we're just simply going to write this out as first. Log x to the power of half. Okay? Because under roots, this under root symbol basically means this. Yeah? If you didn't know this, even if you have cube root of x, that is equal to x 1 over 3. So whatever this number is becomes this. Now, if you had a number, if you had something like root x to the power of 4, 3, this becomes x to the power of 4 over 3. So this 3 comes down here, and this 4 goes up there. Okay? So this was a little bit of a side thing to note, something that you should know, which is kind of cool to know. It just makes life a lot easier when you're dealing with all of this. So what does this become? Now we can go ahead and turn this into half log x. Or you could also say log x over 2. So any of them work really. But you can write this one or this one. They both are pretty good. Okay. Now, the next question. Sorry I didn't give you time to solve the above one, but you can give this question a go. So I'll give you 3 seconds. You can pause the video if you want to give it a go. So 3, 2, 1. I hope you've paused the video and given it a go. If not, once again, that's completely fine. Let's give it a go together. So, what can we do at first? Now we know our log power rule. It's powerful. So we can bring the 8 down to the front since it's an exponent on the 2, right? So that's what we're going to do first. So we've got 8 log 4, 2. But hey, now this is a bit of a problem. What do we raise 4 by to get 2? This can be a little bit easy if you know the trick over here, as I've shown you before. obviously we can't go 4 to the power of 1 because that's too big. And if we go 4 to the power of 0, that's too small. So we need to get a middle ground over here. Yeah? So if you, as I told you before, there's a little bit of a trick. So what you can do over here is we know that 2 squared is 4. That means root of 4 is equal to 2. Okay? That means 4 to the power of a half is equal to 2, as we discussed earlier. So that's why this whole thing, what can happen is that it just becomes 8 times 1 half. And that is equal to 4. Okay? So something to note over here, there's another way to do this actually. If you didn't know that, if it's harder in that case, see, what we see is that 2 raised to 2 is equal to 4. Yeah? So what we can write this as log base 4 2 to the 8. We can write this as log base 4 2 to the 2 to the 2 to the 2 to the 4. Can we do that? Yes, we can. You know why? Because a to the n to the power of m becomes a to the power of n times m. That's an identity of exponents. Okay? So that's why we just multiply this and we get 2 to the power of 8. So it's the same thing. So again, you can bring this forward only. So you would get 4 log 4 2 square. And 2 square is 4, so this becomes 4 log 4, 4. And we know that 4 to the power of 1 is equal to 4, so this whole thing becomes 1. So 4, no log anymore, so 4 times 1, and we get 4. So there are multiple ways to go about this. I find that if you know the little trick, this is more of a quicker way to do this, but again, you can do it any way you like, as long as you get the same answer, you're not doing any wrong steps, you are all goods. So let me just introduce one little homework kind of thing I want you guys to attempt, okay? A question for you. So you can comment it down below and I will check it and let you know if you've gotten it right. So our question is log 2 plus log 5 minus log 10. Now let me just give you guys a hint. The hint is we need to remember to use our product rule, and our quotient rule. So as long as you remember those two rules, you should be good to go. And one more thing that you need to remember is that when there's no base on the log, the base is 10. So we can just write it like that. But we don't need to because that's just a convention. And whenever it's written like that, it's log base 10. So these are a couple of hints for you guys, and I hope you can solve it. And once you do comment your answer down below. So with that, we have finished our topic on logs. I really hope that you guys understood what I was talking about. If you have any questions, please do comment them down below. I've tried to give you the basics to all of the things that are required to solve log questions. To keep up the practice, do go and find some more questions online. It's quite easy to find more logarithm questions. And if you guys are interested, I can do a video about logarithm questions. If you're interested in that, do comment that down below and I will get to it if I get enough people who are interested in that. Other than that, I hope you understood everything. That was our crash course on logarithms, and now you know basically everything you gotta know for logarithms. So, thanks for watching. Remember to like, share, subscribe, and comment your answers / questions / whether you want me to do a video on just logarithm questions or not. So, thanks for watching once again. Bye!